The Earth receives about 173,000 terawatts of solar energy. That amount is 10,000 times greater than the total energy needs of humanity. Imagine such enormous potential. The question is, could the world one day rely entirely on solar energy? To understand this, let's take a look at how solar panels work. Solar panels are made up of small units called solar cells, which are typically made of silicon. Silicon is a semiconductor that is abundant on Earth, and it plays a crucial role in converting sunlight into electricity. Each solar cell has two different layers: N-type, which has extra electrons, and P-type, which has spaces for electrons, called holes. When photons from the sun strike the cell with enough energy, electrons can be knocked loose from their bonds, leaving behind holes. The electric field at the p-n junction forces the electrons to move in one direction, while the holes move in the opposite direction. This process creates an electric current that can be harnessed. That current is collected by thin metal contacts on the surface of the cell, then flows through a circuit to power devices, and eventually returns to the back of the cell. Each cell produces only about half a volt, but many cells combined in a module can power a phone, a house, or even larger buildings. Interestingly, electrons are the only moving parts in a solar cell. There's nothing to wear out or run down, which is why solar panels can last for decades. This is what makes solar energy such a reliable and promising source for the future. However, challenges remain. Solar energy is not evenly distributed across the planet and is not always consistent. At night or on cloudy days, the available energy drops significantly. To rely entirely on solar, we need efficient storage systems and power grids capable of distributing energy from sunny regions to less sunny ones. Efficiency is another challenge. If sunlight is reflected instead of absorbed, or if electrons recombine before flowing through the circuit, that photon's energy is lost. The most efficient solar cells today convert only about 46% of sunlight into electricity, while most commercial systems are currently between 15 and 20% efficient. Even so, it is possible for the world to run entirely on solar power. What's required is investment, technology, and space. Estimates suggest that tens to hundreds of thousands of square miles would be needed. That may sound like a lot, but it's still small compared to the Sahara Desert, which covers more than 3 million square miles. Solar cells continue to become more efficient and more affordable. Innovations such as floating solar farms and next-generation panels may change the way we use solar energy, making it more versatile and accessible. Over 1 billion people in developing countries still lack access to reliable electricity. In many sunny regions, solar power is already a cheaper and safer alternative to kerosene. But in places with limited sunlight, such as Finland or the city of Seattle, effective use of solar energy still requires time and additional solutions. With advances in technology, infrastructure development, and global collaboration, it is not impossible for humanity to move toward a world fully powered by solar energy. The sun provides an abundance of power. If we can harness it, store it, and distribute it efficiently, the future of energy can truly be bright, literally. If you want to discover more amazing facts like this, hit that subscribe button now.